of Java that you might be used to. We have two methods, one called age and another called setAge, that the first one is going to get the age of the thing, and the second one we're going to use to set the age. And similarly down here, we have name and setName. The first we're going to use to retrieve the name, and the second we're going to use to set the name. And these are important names, both by convention, and we'll see things that help us later, where in other languages you might say like get name and set name. Here the convention is just to say name. Do not say get name. Questions? Okay. So looking at the implementation, we must be implementing these four methods. And so notice they are all instance methods. They are all minus. And age, we're just going to return underscore age. Set age, we're going to set underscore age. So we're going to set our instance variable age to the passed in argument age. We're going to return underscore name, and we're going to set, well, this one's somewhat interesting. So we're going to set our instance variable underscore name to name copy. So we know that this syntax is how we're going to send messages to objects. Name is an NS-string object. And so apparently, and you can look in the documentation to verify this, apparently name or NS-string has an instance method called copy that is going to return a copy of this NS-string. And why do you think we want a copy of the NS-string instead of just saying underscore name equals name? Yeah.
Well, because it's an object, you'd be modifying the pointer to that object, so you'd be modifying the initial object.
Yeah, so it isn't, well actually, so if we did not make a copy of the name, it isn't a threat that we are going to modify that NS string, since we don't have any methods for modifying that NS string. I guess if we went around the proper method protocol, we would be doing things. We'll see why we should never be modifying name, but it's possible that the NS string that was passed to us at Bob or something is that could later be changed. And so if that is changed, then if we just do this, then we are also going to, the name within this object will have been changed. So we want to copy Bob for ourselves in case if Bob is ever changed, we don't want to be changed. Okay. So looking at main.m, now this is the better way of doing this. This is like appropriate Objective-C. We're going to see there are more and more better ways, but this is at least like not bad. So we are appropriately initting, and notice that we are allowed to like nest these things. So we could, if we wanted, do student alloc and then Alice equals Alice init, but we are allowed to nest these calls. Okay, and now we are, instead of directly doing Alice arrow age equals 20, which is bad, we are saying Alice set age to 20. We are sending the message set age with the argument 20 to Alice, and we're setting the name to Alice. And similarly with Bob. And then what Greet's going to do is use this sname and sage. We're going to send those getter methods to get getter messages to get the appropriate instance variables. Yeah?
Is it just a syntax convention that you're using to not also nest setting the age?
Oh, so the only reason we can do that here is because student alloc happens to return the student object. And so we are then using that student object and initting it. And that also returns the initialized student object. Set age doesn't return the student object. If we could actually do that, we could do like, instead of void, we could have it return the student object. And then this is going to get into return self. Self is going to be our keyword here. We'll see it later.
Question for the set name. Can we just pass the string value and leave the copy?
So here, are you saying why should we need?
The string by reference. So that's why you need to make a copy. But if you pass it by value,
So this is you never pass objects by value. You never handle objects as explicit values. You're always going to go through a pointer to the object, which is why I say think of like NS string star as the object, not a pointer to the object. Think of it as the object. Except that if you modify it, then it's going to be modified because it's a reference. Okay, so now we're returning self, which is going to allow us to do that nested. Now we're free to do Alice set age 20, set name Alice. Not yet. The next example we'll be able to. Just to point out one other thing that you might see in like documentation or like examples online or stuff. So alloc init is such an incredibly common thing. Like you might be doing some different initializer. There are different initializers, but using alloc and init is so common that there's actually a shortcut new. And so new is going to new is going to first allocate and then initialize. So that does it in one step. There are this is the first of 3 religious wars you'll hear today about Objective-C, that there are a lot of people who say new is a perfectly fine thing, and there are a lot of people who say you should absolutely never use new. So we don't care which you use, whether you want to explicitly allocate and then initialize or whatever. Okay? Questions on any of that? Yes?
So is allocate essentially reserving space on the heap for the object, and init is setting up the instance variables of that?
Yeah, it is potentially doing other things than setting instance variables. If you wanted, you can define an initialization method that like counts the number of objects of this type that have been initialized. But you should never handle an uninitialized object. Okay, so then this is going to be the next example that we're going to want to use, but let's just look at the slide first. So property. So this is going to be what we're going to use to enable us to use dot syntax. We can somewhat ignore a lot of these keywords for now. This assign, copy, strong, weak are things we're going to deal with next week. Strong and weak in particular are pretty much the only things you really need to think about under ARC. So those are memory management difficulties that if you get those wrong, you can still leak things. But it's not too bad. It's especially better than needing to keep track of everything. Atomic and non-atomic are a different pair of things that we'll get into, and read-only and read-write we will talk about today. So at property, new thing. Let's look at the example. Student 3. Okay, so looking at student.h, the only thing that has changed is that we have added these 2 lines. So we have said at property, and from each of those groups that we saw on that property slide, we are picking assign from the first group, non-atomic from the second group, and read-write from the third group. And then we're saying that this instance variable is called int age. So assign, again, you can ignore. Non-atomic, this is just saying that like you can assume that we're not dealing with any multi-threaded type messiness here. you don't have to deal with the overhead of making sure that whenever we modify this age instance field, that you don't have to deal with making sure it's atomic. So atomic just means like it happens instantaneously. We don't have to deal with that. So, and read-write, this is probably, or in this class, you're pretty much only going to be using non-atomic. Read-write is one that if it's read-write, then this property is expecting a setter and a getter. If it's read-only, it's expecting just a getter.